Unlock your digital dreams. This is New Deep Dive.
Welcome to the Deep Dive. We're plunging into the incredible, the unknown, and, well, the utterly mind-bending parts of our universe, our planet, even our own bodies.
Yeah.
Today we're kicking off a journey inspired by just an amazing stack of sources. We're talking cutting-edge research, surprising discoveries, some really fascinating history, too.
Mm-hmm.
Our mission, basically, is to pull out the most important nuggets of knowledge. We want to leave you informed, amazed, but, not overwhelmed.
Right.
So get ready for a deep dive that's truly out of this world.
And we've really curated an extraordinary range of topics for you. I mean, from the farthest reaches of space right down to the biology inside you.
Wow.
Our goal is to distill all this complex info into, surprising facts and those real aha moments. It's kind of a shortcut to being deeply informed on stuff you might not even know you were curious about yet.
All right, let's do it. Let's kick things off looking at humanity's, ambitious leap to the stars. Our sources really highlight just how close we might be to making some big strides in conquering the cosmos.
Yeah, it feels like we're on the cusp of something.
And one of the biggest game changers seems to be the increasing role of AI. Think about it. AI can automate and optimize mission planning, crunch huge amounts of data,
Right.
and even remotely control spacecraft with, unprecedented precision.
Exactly. And this isn't just about convenience, It makes missions way more efficient, more cost-effective. It lets us do more, go further.
Yeah, I could see that. Imagine AI-powered telescopes just scanning the skies, maybe spotting things humans would just miss.
Absolutely. Finding fainter objects, identifying patterns we wouldn't recognize, and building on that efficiency point, the whole revolution in reusable rockets, that's transforming everything.
Oh, yeah. SpaceX, Blue Origin.
Exactly. We're moving past that old model of, build it, launch it, lose it. These reusable systems like the Falcon 9, Falcon Heavy, New Shepard, they're making space travel so much more accessible, much more affordable.
It feels like that single innovation just opens up so many doors, doesn't it?
It really does. It's fundamental to what comes next.
Which brings us to, what we're striving for, actual off-Earth settlements. That dream of colonizing other planets, especially Mars. It's been around for decades.
A long time.
But our sources suggest it's maybe closer to reality than ever? Though it's definitely no walk in the park, right?
Oh, absolutely not. I mean, you're talking months just to get there.
Months.
Then you've got harsh radiation, extreme temperatures. You need totally self-sustaining systems for food, water, air. It's incredibly challenging.
But the payoff, the potential for science, resources, just expanding humanity's footprint.
Yeah.
It's huge.
Immense. And it's not just Mars people are thinking about. There's this concept of terraforming.
Right, changing barren planets into habitable worlds. That sounds like pure science fiction.
It does, but it's being seriously considered. I mean, the timescales are vast, resources needed are astronomical.
And the ethics, too, right?
Yeah.
What if there's already microbial life there?
Exactly. Huge ethical dilemmas. Are you potentially destroying existing life to make way for ours? It's a massive question.
So to even attempt these ambitious projects, you can't bring everything from Earth, which leads to space mining.
Yeah, this is potentially game-changing. Imagine harvesting water ice from asteroids.
Water? For settlements?
For settlements, yes, but also for fuel. You can split water into hydrogen and oxygen rocket fuel, basically, made in space.
Wow, okay. That changes the equation.
Completely. And then think about mining rare minerals, stuff that's crucial for high-tech industries back here on Earth. The economic benefits could be enormous. We're talking about shifting to, a solar system economy.
A solar system economy. That's a phrase. So, okay, we tap into local resources. What's next? Interstellar travel.
That's the dream, isn't it? Going beyond our solar system, and the sources dive into some really mind-bending ideas here.
Like wormholes.
Like wormholes, yeah. These theoretical shortcuts through space-time could potentially cut down travel times dramatically.
If they exist, and if we could use them.
Big ifs. Or consider antimatter propulsion. Using antimatter as fuel would be incredibly powerful, orders of magnitude more than chemical rockets.
Sounds like something out of Star Trek.
It does, but it's rooted in theoretical physics.
Yeah.
These are the kinds of concepts being explored for really long-distance travel.
Okay, so while we're dreaming about wormholes, what's happening right now? What's our actual presence in space?
Well, it's growing. Just recently, we hit a record 17 people in Earth orbit at the same time.
17? From different countries?
Yeah, 5 different countries represented. Most of them, of course, are on the International Space Station, the ISS.
Ah, the ISS. It's amazing that thing is still going strong. It's visible from Earth, right?
It is. It's the third brightest object in the night sky. You can often see it with the naked eye if you know when and where to look. It's whipping around Earth every 90 minutes.
Every 90 minutes. How fast is that?
About 8 kilometers per second. It's really moving.
Wow. And it's huge.
It's the largest human-made object in space. About 110 meters long, weighs around 450 tons. The living space inside is bigger than a 6-bedroom house. Got labs, sleeping quarters, a gym, even 2 bathrooms.
2 bathrooms. Luxury. So what's life like up there? Any weird details?
Oh, plenty. For instance, you mentioned smells. They actually have a designated smell person on the ground.
A smell person? Seriously?
Yeah. They check everything before it launches food, equipment, personal items to make sure nothing has a strong or unpleasant odor. Because, you can't just open a window up there. Ventilation is limited.
That makes sense. What else?
Well, laundry. They don't do laundry.
They just wear dirty clothes.
No, they just discard them. It costs something like $10,000 to send just half a kilogram of cargo to the ISS. Water is way too precious to use for washing clothes, so they wear clothes for a while, then bundle them up to be burned up in the atmosphere on cargo disposal runs.
Wow. Okay, that's practical, I guess.
Mm-hmm.
Any other quirks?
Sleeping. This is crucial. They need constant airflow around their heads when they sleep.
Why is that?
Because in microgravity, the carbon dioxide you exhale doesn't just dissipate like it does here. It can form a bubble around your head. If you don't have air blowing it away, you could essentially suffocate on your own breath.
That is terrifying.
Mm-hmm.
A CO2 bubble. Okay.
Mm-hmm.
And speaking of microgravity, that's not really zero gravity, is it? That's a misconception.
Exactly. That's a really common one. What astronauts experience is microgravity. Gravity at the ISS's altitude is only maybe 10–12% weaker than on the surface.
So why do they float?
Because they and the station and everything inside it are constantly falling around Earth. They're in a continuous state of free fall. Since everything's falling together at the same rate, they feel weightless relative to the station.
Right, like being in an elevator when the cable snaps, but forever.
Kind of, yeah. Just constantly falling sideways along their orbit.
Okay, that makes sense. So if we're thinking about going further, like colonizing Proxima Centauri, that's our closest star system, right? 4.2 light years away.
That's the one.
The challenges go way beyond microgravity and CO2 bubbles. What about the ship itself? How many people would you need for a journey that takes, thousands of years?
Yeah, a generational starship. Early estimates back in 2002 suggested maybe 150 people might be enough to maintain genetic diversity.
150? Seems low for thousands of years.
It is. Newer research, much more rigorous simulations suggest that's way off. To avoid inbreeding and maintain enough genetic variation for a healthy population over millennia, you'd need at least 10,000 people.
10,000.
Minimum. Ideally closer to 40,000.
40,000 people on a starship. How is that even possible?
Well, the thinking is it wouldn't be one single giant ship. It would likely need to be a fleet of modular ships. They could maybe link up sometimes for trade or social interaction, but travel separately to reduce the risk of a single catastrophe wiping everyone out.
Wow. That completely changes the picture. A fleet of city ships heading to the stars.
It's a monumental undertaking, requires a total rethink of deep space travel.
Okay, so that's the very long-term goal. What about closer to home? Space tourism is actually happening now, right? And it's getting quite diverse.
It really is. You've got options now. Our sources mention Space Perspective's Neptune balloon.
A balloon. To space.
Well, to the stratosphere. About 30 kilometers up, it's this luxurious, pressurized capsule under a huge balloon, offers a gentle, quiet 6-hour trip, panoramic windows, comfy seats, Wi-Fi.
How much does that cost?
Around $150,000. It ascends really slowly, like 19 kilometers per hour. It's pitched as a serene cruise to the edge of space. Very different from a rocket launch.
Yeah, it sounds almost relaxing. It reminds me of those early pioneers, like Auguste Piccard back in 1931 with its hydrogen balloon reaching almost 16 kilometers, pushing boundaries.
Absolutely. A modern take on that pioneering spirit. But if you do want the rocket experience...
There are options for that, too.
Oh, yeah. Virgin Galactic has Spaceship Two. It's launched from a mothership, then fires its own rockets to get to about 85 kilometers. Passengers get a few minutes of weightlessness.
Price tag?
Steeper. Around $450,000.
Okay. And Blue Origin?
They have the New Shepard. That's a more traditional vertical rocket launch. Capsule goes up to about 105 kilometers. Passengers get accelerated to maybe 300 to 500 kilometers per hour. Experience weightlessness for a few minutes. That one's around $250,000.
So you can choose your level of intensity, basically.
Yeah.
It's incredible how relatively accessible this is becoming. Some of these flights actually cross the Kármán line, right? The 100-kilometer boundary of space.
Some do, yeah. New Shepard gets above it. Spaceship Two gets close, depending on the exact definition you use. It really makes you think about those early test pilots, like in the X-15 program back in the 60s.
Ah, the X-15. Those guys were really pushing the envelope.
Absolutely. Pilots like Joseph Walker, he was the first civilian to cross the Kármán line, did it twice in the X-15. They were hitting insane speeds, like Mach 7 over 7,300 kilometers per hour.
Mach 7. The heat must have been intense.
Unbelievable. Up to 650 degrees Celsius on the skin of the aircraft. That's why it was built from this special nickel alloy in Inconel X. These flights only lasted about 12 minutes, but the risks were enormous. Those pilots, using really early computers and navigation, their courage directly paved the way for the Mercury, Gemini, Apollo missions.
It really highlights that relentless human drive to explore, doesn't it? Whatever the risk.
It really does. Which kind of brings us to the next part. Exploring the universe itself, not just how we get there, because there's so much more to discover, and some of it is just weird.
Okay, let's shift gears. Beyond human exploration, what about the universe's own quirks, the strange phenomena out there?
Yeah, our sources highlight some truly astonishing cosmic anomalies, things that make you go, huh, like the cosmic hand.
The hand, what's that?
It's this ghostly hand-shaped cloud of gas and dust. It's actually the remnant of a massive star that went supernova. There's a pulsar, a rapidly spinning neutron star right at the palm, powering the whole thing. Looks incredibly eerie.
Wow, like a celestial ghost story. What else?
Then there's Tabby Star, remember that one? It baffled everyone for years because its brightness was dipping dramatically and irregularly.
Yeah, people were speculating aliens, megastructure.
Right. The leading theory now is much less exotic, but still interesting. It's likely a huge, uneven cloud of dust orbiting the star, maybe from colliding comets or planetesimals, blocking the light in weird ways.
Okay, dust. Less exciting than aliens, maybe, but still a cosmic mystery solved. What about closer to home? Anything weird on the moon?
There is that strange gel-like substance found by a Chinese rover on the moon's far side a few years back.
Gel. On the moon.
Yeah. The best guess is that it's probably glass rock melted by a meteorite impact that then cooled quickly into a glassy, gel-like consistency.
Okay. And then there was Oumuamua.
Ah, yes. Our first confirmed interstellar visitor, this kilometer-long, really elongated, cucumber-shaped rock object that zipped through our solar system back in 2017.
And it wasn't bound by the sun's gravity, right? So it came from somewhere else entirely.
Exactly. Its origins are still a total mystery. Was it an asteroid, a comet fragment, something else? Debate continues.
And still lurking out there, supposedly, is Planet 9.
The hypothetical Planet 9, yeah. Believed to be maybe 10 times the size of Earth, orbiting way out beyond Neptune. Its gravity could explain some weird orbital clustering of distant objects we see in the Kuiper Belt. Still hypothetical, but the evidence is suggestive.
So many mysteries just in our backyard, relatively speaking.
Absolutely. And these things aren't just curiosities. They push our physics, make us question our models of how solar systems form and evolve, which leads to another question. Are any of these strange things signals?
Ah, the unexplained radio signals, like fast radio bursts, FRBs.
Exactly. These are incredibly brief, like milliseconds long, but immensely powerful bursts of radio waves coming from deep space outside our galaxy.
More energy than the sun puts out in decades, right? In a flash.
Something like that, yeah. Some of them repeat, some don't. Their origin is still a huge puzzle. One leading candidate is Magnetar's supermagnetized neutron stars, but we're not sure.
And then the classic, the wow signal.
Can't talk about mystery signals without mentioning WOW. 1977, Big Ear Radio Telescope, this incredibly strong narrowband signal lasting 72 seconds right from the Sagittarius constellation, looked artificial.
But it never repeated.
Now vanished. Theories range from, alien probe passing by to maybe a signal from Earth bouncing off some space debris. Still unexplained.
More recently, wasn't there something from Proxima Centauri b, our nearest exoplanet?
There was. A signal detected at 982 megahertz back in 2019, dubbed BLC-1. It seemed to be coming from the direction of Proxima Centauri, and it had characteristics that made it look potentially artificial narrow bandwidth, drifting in frequency like you'd expect from a moving transmitter. But further analysis suggested it was most likely Earth-based radio interference. It's incredibly hard to definitively rule out terrestrial sources. It makes you think, though, about our own attempts, like the Arecibo message sent in 1974.
Right, that binary code picture about us, sent towards the M13 star cluster.
Yeah. Which won't even get there for another, 25,000 years, and then another 25,000 for any reply. It's a long game.
And even if that Proxima signal was real, life there is considered pretty unlikely, right? Because of the star's radiation.
Extremely unlikely, yeah.
Mm-hmm.
Proxima Centauri is a red dwarf star known for frequent, powerful flares. Proxima b is likely tidally locked and bathed in intense radiation. Not a great place for life as we know it.
Okay, so moving from signals to structures.
Yeah.
Cosmic megastructures.
Yeah, these are mind-bogglingly huge. Our sources mention Kipu.
Kipu, like the Incan knots.
Exactly. Named after them because of its intricate filamentary structure, it's the largest known superstructure in our local cosmic neighborhood. A network of galaxies, gas, dark matter, stretching 1.3 billion light years across.
A billion light years. How much mass are we talking?
Estimated mass of 200 quadrillion suns. Just
Yeah.
staggering.
How do these things even form?
Through gravity over billions of years. Dark matter provides the scaffolding, and galaxies trace out these filaments and walls where matter has collected. There are others too, like the Sloan Great Wall, discovered earlier, also over 1 billion light years long.
And these structures actually affect how we see the universe.
They do. Their immense gravity bends the light from objects behind them, gravitational lensing. And they also influence the cosmic microwave background radiation through something called the integrated Sachs-Wolf effect. Basically, photons gain or lose energy passing through these evolving gravitational potentials, which messes with our measurements of the early universe and the expansion rate.
So these giants are actually interfering with our homework.
In a way, yeah, they complicate the picture. And then you have the opposite. Voids.
Like the Boots voids. The giant empty patch.
That's the most famous one. A colossal region of space about 330 million light years across that is remarkably empty, far fewer galaxies than you'd expect. It's one of the largest supervoids we know of. Why it's so empty is still debated.
Okay, from the immense to the maybe slightly less immense, but still weird, Palomar 5.
Yeah.
A star cluster eating itself.
Kind of. Palomar 5 is a globular star cluster, but it's unique because it seems to contain an unusually large number of black holes, maybe over 100.
Black holes in a star collector.
Yeah, stellar mass black holes. And they're actively shaping the cluster. Their gravity is flinging stars out, stretching the cluster into these long tidal streams that extend for like 30,000 light years. It's like the cluster is slowly dissolving.
A river of stars being pulled apart by black holes. Wild. And what about the Cat's Eye Nebula? That sounds prettier.
Oh, it's stunning. NGC 6543. It's a planetary nebula formed by a dying star shedding its outer layers, but it's doing it in puffs, maybe every 1,500 years or so.
So it creates rings.
Exactly, these beautiful, complex, concentric shells and rings of gas and dust. From our perspective, it really does resemble a cat's eye, a spectacular end for a star.
Okay, so we've gone from starships to voids to cat's eyes. What does this all mean when we bring it back home? Are our one planet and bodies just as surprising?
Absolutely. You don't need to look light years away to find mind-bending stuff. Let's dive into Earth itself and even ourselves.
All right. Where do we start? Mega tsunamis.
Mhm.
Sounds dramatic.
It is. Our sources talk about ancient mega tsunamis far bigger than anything in recorded history, like one that hit West Africa ages ago, generated waves maybe 250 meters high.
250 meters? That's taller than many skyscrapers.
Easily. Moving boulders weighing 700 tons inland. These are often triggered by volcanic flank collapses. Imagine a huge chunk of a volcanic island just sliding into the ocean.
Like Mount St. Helens, but underwater?
Sort of, but potentially much bigger. Fogo volcano in the Cape Verde Islands, for example, lost a chunk estimated to be 10 times the volume of Mount Everest in one collapse event. The resulting waves could have swamped the Statue of Liberty 3 times over.
That's terrifying. Are there volcanoes poised to do this now?
Well, many active volcanic islands are inherently unstable. Think Fogo again, Santa Maria, Pacaya in Guatemala, Anak Krakatau in Indonesia, Ritter Island near Papua New Guinea. Their sheer weight, often weak foundations underwater, trapped magma or gases. They're geological time bombs, essentially.
And climate change plays a role, too.
Yeah.
Melting glaciers.
It can, yeah. When huge glaciers melt, the land underneath rebounds upwards. It's called isostatic rebound. This can shift stresses in the crust and potentially destabilize magma chambers or fault lines under volcanoes. Also, you get unstable lava deltas where lava flows into the sea, building new land that can collapse without warning.
We saw a huge one relatively recently, right? Lituya Bay.
Lituya Bay, Alaska, 1958. That was triggered by an earthquake causing a massive landslide into the bay. It generated an absolutely legendary wave. The run-up height, how high the water washed up the opposite slope, was over 500 meters. Higher than the Empire State Building.
Unbelievable. The power locked up inside the Earth. Which brings us to the core. Is that stable?
We used to think the inner core was a pretty simple, solid ball of iron and nickel. But there was a really surprising discovery announced just February 2025.
What did they find?
Evidence suggests the surface of the inner core might actually be deforming, changing shape, possibly due to turbulent, swirling flows in the liquid outer core interacting with it.
The solid core is changing shape. What does that mean?
It could influence how the inner core rotates relative to the rest of the planet, and that, in turn, can actually affect the length of Earth's day by tiny amounts. It shows the core system is much more dynamic than we thought.
So the layers. Inner core, outer core, mantle, crust.
Right. Solid inner core, liquid outer core, that's what generates our magnetic field. The viscous mantle, where diamonds form under immense pressure. And the thin crust we live on.
What would happen if the outer core, the liquid part, stopped spinning?
Catastrophe. Absolute catastrophe.
Yeah.
First, we'd lose the magnetic field.
Which protects us from solar radiation.
Exactly. Cosmic rays, charged particles from the sun, they'd bombard the surface, strip away the ozone layer. Bad news for life. Plus, without the dynamo effect, tectonic plates might start moving chaotically, triggering massive earthquakes and volcanic eruptions everywhere. All electronics would probably be fried. Animal navigation that relies on magnetism would fail. It would be apocalyptic.
Okay, let's hope that doesn't happen. Let's move to something slightly less terrifying. Our own bodies.
Yeah.
Full of surprises, too.
Oh, absolutely. Take your brain. If you go to space, it actually swells slightly, increases about 2% in volume.
Why?
Fluid shifts. Without gravity pulling fluids down towards your feet, more fluid accumulates in your head. It's one of the big physiological challenges for long space missions. Affects vision, maybe cognitive function. Still figuring out the long-term effects for those Mars colonists we talked about.
Huh. Okay. What about senses?
Smell is fascinating. It's often considered our most evocative sense for memory. Studies suggest you can remember maybe 65% of smells after a year.
Better than visual memory.
Often, yeah. But here's a weird thing. You can't actually smell while you're asleep. Your smell receptors basically switch off.
Really? So a fire alarm needs a sound, not just smoke.
Exactly. Your nose won't wake you up. Oh, and get this. Your nose and ears. They keep growing throughout your life.
Hey, what? Why?
It's mostly cartilage, and gravity keeps pulling it down, causing it to sag and stretch over time. So older people tend to have larger noses and ears.
Be looking out for that now. Any other weird facts?
Earwax is actually a type of sweat, produced by modified sweat glands in your ear canal.
Okay.
Your heart is the only muscle that truly never tires over your lifetime, hopefully. And the hyoid bone in your neck. It's the only bone in your body not connected directly to another bone. It anchors the tongue.
Huh. What about our eyes? People compare them to cameras.
Yeah, but the eye blows any camera out of the water.
Oh.
Estimated resolution, around 576 megapixels.
576. That's incredible.
And your lips? Super sensitive, right. They have about 1 million nerve endings. That's maybe 100 times more sensitive than your fingertips.
Explains why paper cuts on lips hurt so much.
Probably. And just like fingerprints, you have a unique lip print. And a unique tongue print. And even a unique body odor. Unless you're an identical twin, apparently they smell alike.
We're just bundles of unique identifiers.
Pretty much. And strong, too. Human bone, ounce for ounce, is about 4 times stronger than concrete.
Wow. And blood types. Anything weird there?
Well, the only difference between the main human blood groups, A, B, ABO, is the type of sugar molecule on the surface of the red blood cells. Type O lacks those extra sugars.
And mosquitoes like type O best.
Studies suggest they do, yeah. Maybe it smells tastier to them. And get this, cows have over 800 different blood groups.
800. Why so many?
Good question. Probably relates to disease resistance in herds over evolutionary time. Oh, and fingernails grow about 4 times faster than toenails.
Why? More blood flow to the hands.
That's the main theory, yeah. More use, more blood flow, faster growth, and digestion. Most adults worldwide actually have trouble digesting milk.
Lactose intolerance.
Exactly. About 68% of the global population loses the ability to produce lactase, the enzyme needed to digest lactose, after infancy. It's actually the ability to digest milk as an adult. Lactase persistence. That's the more recent genetic mutation, common in populations with a history of dairy farming.
Fascinating. What about sleep? Our brains switch off, right?
not at all. Some areas of your brain actually work harder while you're asleep than when you're awake. Consolidating memories, clearing out waste products. Sleep is crucial. Active brain time.
And multitasking. Can we really do it?
Nope, not truly. What we call multitasking is actually rapid task switching. Your brain is just quickly jumping between tasks, not doing them simultaneously. And every switch costs time and mental energy, reducing overall efficiency and increasing errors.
So focus on one thing at a time. Got it. What about habits? The 21-day rule.
Myth. Research shows it takes, on average, about 66 days for a new behavior to become automatic, to become a habit. And it varies a lot depending on the person and the complexity of the habit.
66 days. Okay, good to know. Need more patience. Any other odd body facts?
You contain enough iron to make about 3 small nails, maybe 2.5 centimeters long.
Iron nail.
And enough carbon to make about 900 pencils.
Wow. We're walking hardware stores and art supplies.
Kind of. And you actually glow. Your body emits a tiny amount of visible light due to biochemical reactions, bioluminescence.
We glow like fireflies.
Well, way, way dimmer, about 1,000 times too faint for our naked eyes to see, but sensitive cameras can detect it.
Okay, that's cool and slightly creepy.
Yeah.
So, bodies are resilient, complex.
Yeah.
What about extreme events like lightning strikes? People survive those, right?
Surprisingly often, yeah. About 90% of people struck by lightning survive. But it can have really bizarre consequences.
Like what?
Our sources mention Edwin Robinson. He was blind and partially deaf, got struck by lightning in 1980 while walking in a field, and afterwards he gradually regained both his sight and hearing. Doctors couldn't explain it.
Lightning cured him.
Yeah.
That's incredible.
It is. Then there are cases like Chef Mecha Worf or Kimberly Crone, who reported developing heightened senses after being struck, or even being able to, predict storms by the feeling in their bodies.
Wow. Any physical signs?
Sometimes, yeah. People might faint, have muscle pain, headaches, and sometimes they get these temporary, intricate, fern-like patterns on their skin called Lichtenberg figures.
Fern patterns from lightning.
Yeah, it's thought to be caused by capillaries rupturing under the skin due to the electrical discharge. They usually fade within days, but long-term effects can linger: insomnia, memory problems, mood swings, chronic pain. It's a serious trauma.
Definitely something to avoid. Stay inside during storms.
Absolutely. Get indoors, stay away from windows, don't use corded phones or electronics plugged into the wall, avoid plumbing. If you're caught outside, avoid tall, isolated objects, and don't lie flat on the ground. Crouch down.
Good advice. So these strange occurrences, lightning cures, it kind of makes you wonder, sometimes what we think we see or what we experience isn't quite what it seems.
Exactly. Which leads us neatly into phenomena that are often misinterpreted or are subjects of folklore and misidentification. Let's talk about cryptids, illusions, and maybe pareidolia.
Pareidolia, seeing familiar patterns in random things, like faces in clouds.
Precisely. And Mars is a classic place for, remember those Martian spiders?
Yeah, headlines were wild for a bit, not actual spiders, right?
Not at all. There are these dark, branching channels carved into the Martian surface, some up to 900 meters across. They form in spring when dry ice trapped under the surface warms up, turns directly into gas, and bursts out, carrying dark dust with it. Scientists have even replicated the process in labs. They call them araniforms.
Araniforms. Okay, sounds less scary than spiders. And the rovers keep finding other stuff that looks like things, don't they?
Constantly. Just in March 2025, Perseverance found these little spherical rocks people called spider eggs.
Croc. Well,
April 2023, Curiosity found a small rock that looked uncannily like a hardcover book, maybe broken in half.
a Martian library.
Just a rock. January 2023, a formation looked like a bear's face. February 2022, a beautiful structure nicknamed a mineral flower, likely a deposit of minerals precipitated from water long ago. 2021, there was that perfectly rectangular doorway and a cliff face, just a natural fracture.
So lots of rocks looking like stuff. Pareidolia in action.
Exactly. And it's not new. Remember the square rock back in 2001? Or the most famous one, the face on Mars from the Viking orbiter photos in 1976?
Oh yeah, the face looked like a giant carving.
It really did in that low-resolution, specific lighting angle photo. Later, higher-resolution images showed it's just a natural mesa, a worn-down hill, no ancient Martian structures involved.
But Mars did have water, right? So maybe life wasn't impossible back then.
Oh, absolutely. The evidence is overwhelming now. Mars had rivers, lakes, maybe even oceans, probably between 4.1 and 3 billion years ago. It was likely warmer and wetter.
So microscopic life could have existed.
It certainly could have. That's one of the key things missions like Perseverance are looking for evidence of. Scientists think Mars slowly transformed into the cold, dry desert it is today as its atmosphere thinned and it lost its magnetic field. Those Martian blueberries, little iron-rich spheres found by the Opportunity rover, are strong evidence of past water soaking the rocks.
Okay, so pareidolia on Mars. What about mysteries here on Earth? Cryptids.
Right, creatures of folklore, like Mokele Mbembe in the Congo River Basin.
The supposed living dinosaur, like a sauropod.
That's the description, yeah. Long neck, lives in the swamps. Reported sightings have apparently increased recently, though still no physical evidence, no photos, no bones. Cryptozoologists cling to the idea it's a relic dinosaur.
But scientists think.
Scientists generally attribute sightings to misidentification of known animals, floating logs, optical illusions in the swampy environment, or just folklore evolving, maybe influenced by ecosystem changes or increased human activity in the area.
Okay, what about the Mongolian death worm? Sounds delightful.
Doesn't it? A mythical creature from the Gobi Desert. Descriptions vary, but generally a thick red worm, maybe up to 1.8 meters long, supposedly spits corrosive acid and can discharge electricity.
Acid-spitting electric worm?
Right. Westerners first heard about it seriously from the paleontologist Roy Chapman Andrews in the 1920s, who recorded local beliefs. But again, zero evidence. It's most likely based on sightings of a local snake, probably the Tartar sand boa, which is harmless, or maybe a type of legless lizard.
Misidentified snake becomes legendary monster. Seems common. And the Lake Worth monster. Texas, right?
Yeah, Lake Worth, near Fort Worth, Texas. Summer of 1969. Reports this creature kind of a goat-man hybrid covered in scales or white fur with claws. It supposedly terrified people, even threw a car tire at witnesses.
Oh, a tire, okay.
There's one famous, blurry photo, but it's widely considered a likely hoax, possibly teenagers pulling a prank, but the legend stuck. They even have a Lake Worth Monster Bash Festival sometimes. It becomes part of the local identity.
From prank to festival. That's quite the legacy. So these are earthly mysteries, likely misidentifications or folklore. What about strange things in the sky? Often turn out to be less mysterious, too.
Very often, yeah. Especially with more rockets launching and satellites orbiting. Remember those blue spirals seen over Europe recently in 2025?
Vaguely, what were they? Alien portals?
No, they were actually caused by SpaceX Falcon 9 rockets. After deploying their payload, the upper stage vents excess fuel before deorbiting. This vented fuel freezes instantly in space, forming a cloud of ice crystals. When the sunlight hits this cloud at the right angle, especially during twilight, it reflects blue light and the spinning motion of the stage creates that spiral shape.
Frozen rocket fuel. Okay, less exciting again. What of those trains of lights people see?
Ah, the Starlink trains. Those are strings of SpaceX's Starlink internet satellites shortly after launch, before they spread out into their final orbits. They're quite close together initially, and their solar panels reflect sunlight, making them look like a bright train moving across the night sky.
Causes a lot of UFO reports, I bet.
Definitely. And sometimes after rocket launches, especially around dawn or dusk, you see these spectacular luminous cloud shapes expanding high in the atmosphere. People call them jellyfish clouds sometimes.
What causes those?
Again, it's the rocket's exhaust plume, water vapor, and other particles way up in the stratosphere, mesosphere, catching the sunlight long after the sun has set, or before it has risen, for observers on the ground. It creates these beautiful, glowing, noctilucent cloud effects.
So rockets are responsible for a lot of weird sky stuff. Are there natural atmospheric illusions too?
Oh yes, plenty. There are things called ELVEs, emission of light, and very low frequency perturbations due to electromagnetic pulse sources.
Catchy name. ELVEs.
Yeah, they're huge, brief, donut-shaped red rings that flash high above powerful thunderstorms in the ionosphere, maybe 100 kilometers up, caused by the electromagnetic pulse from intense lightning strikes exciting the nitrogen molecules up there. They only last a millisecond.
Wow. Hard to spot then.
Very. Then there are SAR arcs. Stable auroral red arcs. These aren't aurora, but they look like faint, stable red glows stretching across the sky, usually seen at lower latitudes than typical aurora. They're caused by energy from Earth's ring current heating oxygen atoms in the upper atmosphere during geomagnetic storms.
Red arcs. And astronauts see stuff too. Blue flashes.
They do. Astronauts on the ISS have reported seeing blue flashes originating above thunderstorms. These are different from ELVEs, maybe related to discharges between the tops of clouds and the ionosphere. They've also seen blue flashes from moonlight reflecting off the atmosphere in specific ways.
The view from up there must be incredible. One more illusion?
Light pillars.
Ah, light pillars. Those look amazing, like beams of light shooting straight up into the sky from bright lights on the grounds,
Yeah.
streetlights, cars.
I've seen pictures. What are they? It's an optical illusion caused by light reflecting off tiny, flat, hexagonal ice crystals drifting in the air, usually in very cold, calm weather. The crystals act like millions of tiny mirrors, reflecting the light vertically, not beams going up, just reflections coming down to your eye.
So lots of explanations for weird lights, which brings us to that Antarctica story. NASA finds a parallel universe where time runs backward.
Oh boy, that one went viral in 2020, didn't it? Total misrepresentation of the science.
Okay, debunk it for us. What actually happened?
So there's an experiment in Antarctica called ANITA, the Antarctic Impulsive Transient Antenna. It's a balloon carrying radio antennas high over the ice sheet, looking for radio waves generated by ultra-high-energy neutrinos interacting with the ice.
Neutrinos, the ghost particles.
Exactly. They usually pass right through matter. ANITA detected a couple of events where high-energy particles seem to be coming up out of the ice from below the horizon, which is weird because particles at those extreme energies shouldn't be able to travel all the way through the Earth. The Earth should block them.
So something strange was detected.
Yes, an anomaly, an unexplained observation. Now, some theoretical physicists trying to explain this anomaly proposed some very exotic ideas. One was the possibility of a CPT symmetric universe.
TPT, charge, parity, time.
Right. A hypothetical universe created in the same Big Bang as ours, but where charge, parity, like left-right mirror image, and the direction of time are all reversed. In that kind of universe, high-energy particles might behave differently. It was a highly speculative, theoretical paper trying to fit the data.
And the media ran with, NASA finds parallel universe.
Pretty much. Sensationalized a theoretical explanation for an anomaly into a confirmed discovery. NASA didn't find a parallel universe. ANITA found some puzzling signals. There might be more mundane explanations, weird ice properties, reflections, maybe a misunderstanding of neutrino physics at those energies.
So no proof of multiverses from Antarctica? But the idea itself, parallel universes,
Yeah.
It's still out there in physics, right?
Oh, yeah. It's a fascinating area of theoretical physics. You have the many worlds interpretation of quantum mechanics, string theory landscape suggesting bubble universes with different physical laws, even ideas about universes existing within dark matter halos. But these are all mathematical frameworks, theoretical possibilities, no direct observational evidence yet.
Intriguing, but theoretical. Got it. Okay, let's shift gears again. From cosmic mysteries and illusions to something more tangible, future tech that could change our lives here on Earth.
Right. What amazing innovations are on the horizon? Our sources point to some exciting developments, like wireless electricity.
Wireless power. We kind of have that already, don't we? Phone chargers, toothbrushes.
We do, yeah. That's short-range inductive charging. But the vision is much bigger, transmitting significant power over longer distances without wires.
How would that work?
Different approaches are being developed. Our sources mention companies like AirCord working on using infrared laser beams to transmit power. Imagine focused beams carrying energy to devices like smart locks, sensors, even small video screens, eliminating the need for batteries or wiring.
Lasers carrying power. Is that safe?
Safety is obviously a huge consideration. They use low-power infrared and often incorporate safety mechanisms to shut off if the beam is interrupted. It's designed for specific, targeted applications initially.
Didn't Nikola Tesla dream of this, like, globally?
He did. His Wardenclyffe Tower project was an attempt to transmit electricity wirelessly through the Earth's ionosphere. Visionary, but ultimately unsuccessful and perhaps impractical on that scale with early 20th century tech.
So what are the modern, maybe more practical approaches for longer distances?
Microwaves are one option. They can transmit power over kilometers, though the beams spread out, so efficiency drops with distance. Lasers offer a more focused beam, better for point-to-point power transmission.
What could you use that for?
Imagine charging drones while they're flying, powering remote sensors without batteries, getting emergency power to disaster areas quickly, maybe even beaming power down from space.
Power from space.
That's a big one. Japan, for instance, has ambitious plans. They're aiming to potentially have a gigawatt-scale space-based solar power plant operational by the 2030s.
A solar power plant in orbit, beaming energy down.
Exactly. Collecting solar energy 2047, converting it to microwaves or lasers, and transmitting it to receiving stations on Earth. Huge potential for clean, continuous energy if they can overcome the engineering and cost challenges.
Wow. That's a future worth working towards. What about other clean energy breakthroughs?
Hydrogen is another big area, specifically generating hydrogen cleanly. Japanese scientists recently made a breakthrough with a new type of reactor.
What does it do?
It uses special photocatalytic sheets materials that use sunlight to drive chemical reactions to split water directly into hydrogen and oxygen. Just sunlight and water in, clean hydrogen fuel out.
That sounds perfect. No carbon emissions.
Right. Hydrogen burns cleanly, producing only water. The challenge has always been producing the hydrogen itself efficiently and without using fossil fuels. This direct solar water splitting is very promising.
Is it efficient enough yet?
Not quite for large-scale commercial use.
Nice.
The current reactor achieved about 1% solar to hydrogen efficiency. They need to get that up to maybe 5% or more to be economically viable, but it's a significant step. If they can scale it up and improve efficiency, it could be huge for renewable energy.
Okay, so wireless power, clean hydrogen. The future looks bright technologically. Let's wrap up our deep dive with maybe the biggest question of all. Are we alone?
Yeah, the search for extraterrestrial life, it feels like we're getting closer to maybe finding some answers, or at least strong hints. Powerful tools like the James Webb Space Telescope are giving us unprecedented views of exoplanet atmospheres.
And one planet in particular has been getting a lot of attention, right? K218b.
That's the one. It's about 124 light years away in the constellation Leo. And it's fascinating because it seems to be what astronomers are calling a Hyson world.
Hycene.
Like hydrogen ocean.
Exactly. A potential water world covered in ocean, but with a very thick, hydrogen-rich atmosphere. It's a relatively new theoretical class of exoplanet, and K218b might be our first real example.
And Webb found something interesting in its atmosphere.
It did. It confirmed the presence of methane and carbon dioxide, which was expected for a Hyson world. But it also found a tentative detection of dimethyl sulfide, DMS.
DMS, why is that significant?
Because, here on Earth, DMS is almost exclusively produced by life, primarily by phytoplankton in the oceans. Finding it on an exoplanet would be, well, a very strong potential biosignature.
Potential sign of life, wow. Is it confirmed?
Not yet. The DMS detection is still tentative, maybe around 2 or 3 sigma confidence. Scientists need to reach that 5 sigma gold standard for a discovery.
5 sigma, less than 1 in 3.5 million chance it's a fluke.
Right, so more observations are needed. Plus, DMS have been found elsewhere, like on comets, though usually in much smaller amounts. And there could potentially be unknown non-biological ways to produce it under the conditions on K218b. So caution is needed. And is K218b even habitable? I thought there was debate about its temperature.
There is. It's in its star's habitable zone, the region where liquid water could exist. But because of its thick hydrogen atmosphere, which is a powerful greenhouse gas, some models suggest its surface might actually be too hot for liquid water, maybe even having a boiling ocean. Others suggest it could be just right. We need more data.
So, tantalizing, but not proof yet. Are there other promising candidates?
Oh, plenty. We already mentioned Proxima Centauri b, closest exoplanet, rocky super-Earth in the habitable zone, but that radiation problem is serious.
Right.
Then there's the TRAPPIST-1 system, 39 light-years away, 7 rocky planets around a cool red dwarf star. TRAPPIST-1 looks particularly promising, might have more water than Earth, possibly a stable climate.
7 planets, amazing system.
It really is. Kepler-186, about 500 light-years away, was the first Earth-sized planet found in another star's habitable zone. It orbits a red dwarf too, which are very long-lived stars, giving life potentially billions of years to evolve.
More time for life to get started.
Exactly. LHS 1140b, 40 light-years away. Another rocky super-Earth, maybe with a dense atmosphere, lots of water, and orbiting a relatively calm star, which is good for habitability.
And that new Venus-sized one, Gliese 12b.
Yes, Exenus, also about 40 light-years away. It's roughly Earth-Venus-sized, and its estimated surface temperature is around 42 degrees Celsius, assuming it has no atmosphere. That's pretty temperate.
So what's key about that one?
It's a fantastic target for Webb to study its atmosphere, or lack thereof. Understanding why Earth kept its atmosphere and became habitable while Venus became a hothouse is crucial. Gliese 12b, being similar in size and temperature, could provide vital clues about how Earth-sized planets maintain atmospheres around these cool stars.
So lots of targets, lots of potential.
Absolutely. While we don't have that definitive confirmation of life elsewhere yet, telescopes like Webb are giving us the tools to seriously investigate. And we shouldn't forget the potential for life closer to home, too, under the ice of Jupiter's moon Europa or Saturn's moon Enceladus, both thought to have subsurface oceans.
The search continues, both far away and right here in our solar system.
It does. It's an incredibly exciting time for astrobiology.
Well, this deep dive has been quite a journey. From starships and space tourism to cosmic ghosts, living planets, weird bodily functions, and glimpses of future tech. We've covered a lot.
We certainly have.
It really feels like we've only just scratched the surface of what's out there, and even what's right here.
And, this raises a really profound final thought, doesn't it? As we keep discovering more about the sheer vastness and complexity of the universe, about the hidden wonders on our own planet, even inside our own bodies, it constantly challenges our understanding.
Yeah, it makes you question what you thought you knew.
Exactly. So what fundamental truths might still be out there just waiting for us to uncover? Truths that could change absolutely everything we think we know about reality and our place within it all. That's the big question that keeps driving us forward.
Subscribe to New Deep Dive.